Sorry about that. Members of the committee, Eric Caceres with the city's program manager for the WRF. I wrote down 3 questions. I hope I got all of them. The first one had to do with the loan agreement status. So the city is currently pursuing 2 low-interest loan opportunities. The first one is the WIFIA through the EPA. The city submitted their application last year. That application is in review. We're going through both the technical review as well as the environmental review. Part of completion of that environmental review is also going through in coordination with the State Historic Preservation Office. We're currently in the process of doing that. We anticipate that we're going to have loan agreements ready at the end of the summer. We are currently working on finalizing the loan agreement, and then another thing that the city has to go through and do, because of the nature of the city can't issue bonds, and so they have to put together an organization that will allow them to issue that debt. So that process is ongoing currently as well. So all of those different things are happening right now, which will allow the city to get a signed loan agreement with WIFIA at the end of the summer. The city was also recently selected, or in the draft intended use plan that's been put out by the state board. The city has been selected to receive $105 million from the state revolving fund, the Clean Water State Revolving Fund. That fundability list, as part of the intended use plan, will be finalized on June 18th at the state board meeting. So we will know for sure whether the city is going to receive that funding on June 18th, or is eligible to receive that funding, I should say. That's going to be a bit of a long process to get a signed loan agreement for SRF, but those are the status of the 2 loans. The second question had to do with the pipes around Lila Kaiser Park, and I believe the reference was to the rerouting of the pipes to the east injection location if we do go to the east injection location. Those 2 modifications to the project are currently part of the EIR addendum that we have our environmental consultant working on, and that will be coming back to council. It will be circulated per the requirements of the state revolving fund process, and will be brought back to council likely in the August time period. The third question had to do with the hydro-geo reports, I believe. So I can begin to answer this. The first phase of the hydro-geo work is what we're going to be presenting on tonight. There are 2 other phases, phases 2 and 3, that we need to get through before we can do the final design of the injection wells. And I go through that quite a bit in the presentation here this evening.
All right, thank you, Eric. Next item is our consent calendar. Items A1, A2, A3, A4, they're minutes from previous meetings. Does anybody have any comments on the committee?
I make a motion to approve the minutes as stated for the May 1. Are we going to do all 3 at the same time?
It's all consent.
Oh, okay. Honestly, I wasn't at one of the meetings, so I wasn't going to make the motion on that meeting since I wasn't there. If somebody else wishes to do it.
What item was that?
Well, I wasn't at the most recent meeting, the one in beginning of May, what was it? The last one was May 9th, 2019. I was absent at that.
So do you want to move for approval for A1, A2, and A3 then?
That'd be great. I'll make a motion to approve the minutes as stated on the first 3 meetings.
Any second?
Second.
All in favor say aye.
Aye.
Opposed? There are none, that passes. So item A4, where Steve wasn't here, would someone like to make a motion on that?
Make a motion.
Okay.
I was here.
All right. Move for approval for A4?
Yes.
A second?
I second it.
Okay. All in favor say aye.
Aye.
Aye. Opposed? None. That passes. Brings us on to our item, business item B1, which is submission of the concept design report, and hand it over to the staff.
Thank you. So we prepared a presentation here this evening that we're going to go through. The staff report covers really two items. The first one is the formal submission of the final draft concept design report. The second item is a review of the groundwater modeling technical memorandum, as well as just a general update on the status of the hydrogeological investigations to support the potable reuse permitting of the project. We'll take a brief pause after both pieces, and we can you can ask any questions, and also feel free to stop me with any questions you might have as we go through here. So our recommendation here tonight is that you accept the final draft concept design report and provide comments and input on the presentation for the groundwater modeling technical memorandum. So we'll start with the final draft concept design report. The concept design report for the conveyance facilities, and I want to be clear that we're speaking about just the conveyance facilities here, is really, it's supposed to identify the siting, design criteria, project constraints for the water reclamation facility lift stations, and also identify the alignment design criteria and any constraints for the offsite pipelines, those being the sewer force mains, the two sewer force mains, the brine or effluent line that'll go from the new facility at South Bay Boulevard to the existing outfall, communication conduit that's going to be running in the common trench, and the IPR line that's going to bring potable reuse water either to the west or east injection locations. So we first brought the information in this concept design report to WRF-CAC on December 17th of last year. We then brought a very similar presentation to council in January. We were directed to come back to council in February to revisit the item, mainly so that council could take formal action on the selection of two critical items, which was the alignment and the configuration or number of pump stations. And so I'll go through that a little bit more here as we review the concept design report information. This is just a timeline that takes us way back to November of 2017, when the city formally selected Waterworks Engineering as the design engineer for this component of the project. Went through a number of design meetings in spring 2018 when Carollo came on as the new program manager. The Blue Ribbon Commission considered a number of elements for the conveyance facilities project when they developed their report in June of 2018. We brought the concepts for the alternative alignments and pump station alternatives to WRF-CAC in December of 2018, along with our recommendations. Again, on January 22nd of this year, we brought it to council. We're directed to come back to council again on February 13th. And now we're here at WRF-CAC, and this is June 4th. Plan is to bring this to council next week, a very similar presentation, overview again, and just formal receipt of the report. And the final concept design report will be delivered in September of 2019. The reason for that delay is essentially that the design engineer is planning to deliver the final of this report along with their 60% design submittal that's expected in September of this year. So the sequence of the concept design report and the way that the report reads and the analysis was completed is shown in this flow chart here. First started looking at and confirming the design capacity for the pump stations and the pipelines. We then went through a pipeline optimization, looking at the size and number of pipelines, then looking at the route analysis for the pipelines. Once that was determined, then the pump station analysis was performed, finally resulting in the preferred alternative. That really constitutes the end of the concept design report, and then we have the final design. And as we go through and talk about next steps, I'll go through the different deliverables that we're anticipating and that Waterworks is contractually obligated to provide the city. So quickly on the design capacity, the design engineer looked at a number of sources of information in order to come up with the design flows for the pump stations and the pipelines. Really three main sources of data. There was a facility master plan information for the facility master plan from 2017. There's historical flow meter data. The city collects flow meter data and has done that for a number of years. And then the One Water Plan. Part of the One Water Plan included a detailed flow analysis performed by Villalobos and Associates back in 2016, 2017 in order to inform the One Water Plan, and specifically the collection system master plan component of that project. The result was a determination for the Brine or the Outfall pipeline that should be sized for the max hourly flow capacity for the treatment plant, which is 8.14 MGD. And then the IPR pipeline, which would be designed for 0.8 MGD. The main treatment plant, the treatment plant itself would be designed for an annual average flow of 1 MGD. So the way that we got to that 0.8 MGD is you take the 1 MGD that's going to be treated on an average basis by the water reclamation facility, and once you pass that water through the reverse osmosis project, it's at an 80% recovery, and so you take 80% of that 1 MGD, and that's the water that we have available to put into the ground, is 0.8 MGD. Then looked at pipeline optimization. Again, this was something that was considered during the time of preparation of the Blue Ribbon Commission report, and was also discussed at length in December and January and February. Previously is the alternative of using 2 separate sewer force mains. Because of the nature of the flows that the city's treatment plant is going to see, they go down into the hundreds of thousands of gallons per day during low dry weather flows, all the way up to 8.1 MGD anticipated for the wet weather flows. So the proposal was to use 2 separate force mains, one smaller, one larger. The small one would be used during average dry weather conditions. The larger one would be used during wet weather conditions in conjunction with the smaller, also giving the system a bit of redundancy as well. The Brine Outfall pipeline was sized a 16-inch diameter, looking at a number of different materials. And the IPR pipeline is envisioned to be an 8-inch diameter. Also looked at a communication conduit to provide fiber along the pipeline alignment to connect the different pump stations. That's a 4-inch diameter conduit. A route analysis was performed. First, a number of different working alignments were identified. Then went through the process of identifying the criteria by which those alignments would be evaluated, and as well as some of the major constraints. Then we went through a fatal flaw analysis to figure out which of these alignments just wouldn't work, regardless of cost or other reasons. They were deemed as being non-viable. The ones that were deemed viable made the list of final alignments. Those were assessed on using cost and non-cost factors, and we came up with the preferred alignment alternative. This figure up here shows the 5 different alignments that were considered. There's the 3 on the east of Highway 1, as well as 2 different alignments to the west of Highway 1, with the 2 west alignments being the alignments that were not fatally flawed and went through a detailed analysis. The Embarcadero alignment and what we deemed the west alignment, the one that runs in Main Street and the bike path and Quintana. Pump station analysis was performed. Originally envisioned the system would operate with a single large pump station that would be located near the city's existing courtyard. Based on a review of flows and some additional analysis, the dual pump station concept was identified. It was identified to have a lower capital cost than the single large pump station, and had some other ancillary benefits, the ability for the city to reuse existing infrastructure and other benefits. And so the determination was made to move forward with the dual pump station option. Again, as was mentioned previously, the city's currently putting together an addendum to their final EIR. That final EIR addendum is including this pump station B, which is located near the intersection of Highway 1 and Main Street. This figure here shows the preferred alignment with the 2 pump stations identified and the alignment as it currently exists. Again, a couple of small changes in the alignment. Again, the pipelines are no longer running through Lila Kaiser Park based on some input that we received from some concerned Native American groups. that's now running in Atascadero Road and then running in Caltrans right away and avoiding that. We're also have slightly realigned the potential pipeline out to the east injection location, so that goes all the way up to Atascadero Road, as well as reconfiguring the alignment at the south end where we've got the pipeline going along Quintana all the way to South Bay Boulevard and not going with a trenchless crossing of Highway 1. Over to the right-hand side of that map is a shot of our existing trench detail. One of the things that was noted in the staff report and wanted to highlight here briefly is this report was initially drafted in November of 2018. Again, we're now in May 2019 and presenting the final draft. Very few changes have been made to that document. The one critical item to point out, and is something that we've noted in the last several monthly status reports for the project, is the schedule for this component of the program has been impacted by the ability for the city to access a couple of properties that are critical in order to design the pipeline. Mainly as we move from a 30% to the 60% design. A really important component of that is getting the survey completed, as well as the geotechnical investigations completed, and getting that information to inform the design. And we've had some challenges in accessing the PG&E and Vistra properties that we've now worked through. The surveying for both of those properties was completed last week. And we're currently working to get the geotechnical work done in June so that the project can progress. But this table here identifies the slippage in the schedule by several months, kind of all the way down the line, and that's really being triggered by the 60% design submittal being pushed out several months. And this is just a little bit of detail showing that where that slippage is coming from. So that is the concept design report. Questions?
Steve, go ahead.
Oh, okay, thanks. The first one, this is an easy one. I know what HDPE is. I know what PVC is. What's the F in front of the P?
It's fusible PVC.
Oh, okay, so you're going to plastic weld it.
Plastic welded, exactly.
The second thing, and this is more of a request or a humble request, could we please get printed copies of the stuff? I had to be looking at an iPhone all weekend trying to read it, and I must admit, I wasn't able to do it as carefully as I ordinarily would have. So I'm going to ask you real quick, Eric. There's a few questions in my mind after your presentation that I'm still not clear on. Is lift station 2 and 3 existing lift stations that are presently in place right now?
That's correct.
Oh, okay. And then the PS, so basically the LS2 ties in before you get to the PSB. I just wondered if there's a reason why you didn't go on the other side, because you have that one pumping again, what's coming out of the LS2. And is it physical constraints that it was easier to tie in at the location that's shown?
Yeah, it's physically easier to tie into the location where it's shown, yeah.
Oh, okay. And then the second question, the way I understand is you're going up Atascadero Road, you're going to jump into the Caltrans right away at those on-ramp and off-ramp that goes over to Main, then jump back out of Caltrans.
Correct.
Run over to Quintana, up Quintana, under the roundabout, down, I'll call it South Quintana, until you get to South Bay. So that is the alternative that you are proposing as part of the preferred one.
That's correct. As I mentioned previously, the two differences between, well, there's really three differences between what was in the environmental document and what's currently being shown is, again, we're not going through Lila Kaiser Park, as you mentioned, we're not going around, going through Caltrans right away. The other change is we are not going to go, originally we were going to go trenchless underneath Highway 1, cutting under Highway 1 roughly at what would be the northern end of Teresa Road.
Oh, okay, yeah, you went away, you
Yeah.
got away from that.
Rather than
yeah.
going all the way down to South Bay Boulevard. But when we started having some additional discussions with Caltrans, they indicated, and we got some information on those structures, and we identified that we'd be able to open cut underneath that overpass.
So the abutments don't come into play?
The abutments are not an issue
okay.
there, so that made that easier. And then Teresa Road has a lot of utilities in it, and then there was also some issues with some stormwater infrastructure there at Highway 1 that made it easier for just to
Well, if they're allowing you to open cut, it's got
less
to be the
expensive as well.
cheapest alternative to it. The only reason I was asking about whether it was on the west side of Highway 1 there, along those on-ramp and off-ramp, was there was a discussion in there, and I wasn't sure quite where it was going, because it talks about the easterly and westerly IPR alignment coming back, but you're showing a common trench.
Correct.
If you have the easter, let's say you decide that the east makes more sense to do the injection wells on, are you going to follow the west alignment till you get pretty far over there, maybe directional drill under the freeway or something?
Yeah, so we can also open cut underneath the freeway there at Atascadero Road as well.
Okay.
That was the other thing that was identified. So the environmental document had looked at not running those in a common trench and running the, let's say, the dirty water side in its own trench on the west side, and then the IPR line they would run up the east, with the idea that you would come over, if you were going west, you would directional drill under the freeway, and then go west if you were going to the west injection, continue going along the east side up to Errol, I believe, and then cutting over into the east. That was what was in the environmental document.
Oh, okay.
The reason for that was the information available at the time weren't able to determine if we would be able to fit all of that infrastructure in a common trench and make it work in Quintana specifically. And so once we looked at it in a little bit more detail and determined that we could do that and had a strategy to work with DDW to make that happen, it was less costly to run it all together on the west side and then cut over to the east if we decide to go to the east, which is...
Right,
yeah.
exactly. But you're not going to try and get over there early.
No, and we're, the idea is, and obviously as we go through here and talk a little bit more about the hydrogeo work, our preference is to go to the west. Now, we're carrying the cost of going to the east for the IPR in our current cost estimate, but it is more expensive, I want to say, to the tune of somewhere north of $1 million to go to the east. We just don't have enough information yet on the injection, those two different injection locations, to make that final determination of where we're going to go. So.
And then the other question was regarding the brine outfall. I'm not sure, but I thought I read in there that 8.14 million was the peak hourly flow design, wet weather.
That's correct.
For influent to the plant, why would the brine be sized to the exact same? Some of it I thought was turning into water for indirect potable reuse.
Yeah, and then there will be times when the IPR is not running, and likely during a storm event when Mr. Miller and his staff are seeing
and you're dumping
8.1 MGD, they'll probably not be running the advanced treatment side and sending it all through the other side and all to the outfall.
Oh, okay. And the brine line, I assume it's true gravity. It's just a reverse siphon or something like
it
that.
It is a gravity line.
It is. There's no pumping on it, I assume.
Yeah, it's pumped to the high point, and then it flows by gravity. Yeah.
I thought the high point was the plant itself.
No, it has to get back over up to Quintana and.
Okay, because when they showed the profile, and like I said, I'm reading this off an iPhone, so it wasn't the easiest thing. It looked like the highest point was I thought it was like 7-8 feet lower at that high point that they showed on that alternate. I may be wrong, but so you will have to put up a pumping system.
We do have a pump station that gets it up to Quintana and Kings.
Oh, okay.
Yeah.
Okay, thank you.
That's what breaks it.
A couple of quick questions. I thought I saw on the plan sheet that in the vicinity of Lilac Park that you have something that's called a raw water line. I think it was color coded in pink. And it actually encircles Lilac.
So
Is that a new line, or is that an existing line, or
That's an existing line.
so that you'll keep in place?
Is this the realignment? I think it's a well, yeah.
So, you know what I'm talking about, it's on the, I think it's one of the first couple of plan sheets. And it's labeled raw water. So, I just wanted to know if that was new construction or,
That's existing water line that either has the ability to feed the brackish water RO plant or can be valved to go directly to Kings.
okay. The other question I had is, in the report, it discussed the pump station 2, that's city-owned property, is that true?
That's correct.
Okay. I was looking at the plan sheet for the eastern end of the project, and it still includes the Teresa Lane crossing as a possible option on the plan sheet. I don't know if it sounds like it's been dropped.
Yeah, that's been
But I
dropped.
just wanted-
The plan is to not go
Okay.
trenchless at Teresa,
Yeah.
that's correct, yeah.
Just that it's there. Okay. That's all I have.
Doug, do you have any comments? Questions? There you go.
Okay, thank you. I thought we were going to be talking about the GSI report today, so.
Well, that's coming up still.
Oh, okay, then I'll wait.
You wait till then?
Yep.
Okay. I have a couple questions. I just noticed on your slide that you just showed that the final CDR is September 2019, but this report says final draft on it.
That's
Is there
correct.
going to be why is this called final now? If it isn't going to be final till September?
We've the decision was made that it's a final draft, so it's not a final document. We're going to final the document so that it matches any changes that may occur with the 60%, and so that was a decision that was made between the city and the design engineer and the team. So that 30% design is the most updated that it can be. Right now, it's as updated as it can be. We don't anticipate any changes, but the plan is that we would formally finalize it and make hard copies of it and everything else there in September.
Just a little to add, we still have to get a coastal development permit tentatively scheduled for July hearing, and there may be changes they request during the coastal permit hearing. Don't anticipate any, but wanted to leave that option open.
Doesn't coastal staff need to know this information that's in this document as they prepare theirs?
They have this document.
They have this document?
Yes.
Okay. I noticed, and it's on several places, but started on page 8, that 8.14 million gallons a day, they say that, they have it listed under 2040 future conditions, where presently it says hourly it's 5.85. To me, it seems to me that over that next 21 years, that, our RNI is getting worse, that we're going to be seeing higher winter flows in the future than we presently see now? Is that what that means to me?
Yeah, I'd have to go look and see what it says there for current. The 2040, one of the interesting things that occurs with, and this was something that we talked about when the One Water Plan was presented, is the city has some hydraulic bottlenecks in the collection system, and so one of the issues with fixing some of those hydraulic bottlenecks that are currently creating surcharge conditions in the collection system during these different storm events is we're going to upsize and replace those pipes. And so when that's done, you can actually pass more flow. So the peak hour flow, instantaneous peak hour flow, will go up a little bit during I&I conditions. So hydraulically, we have to design for that in the pipelines. So we are going to be fixing pipes and fixing I&I. The problem is we're going to be increasing the hydraulic capacity of the system to a certain extent. So we will see a slight bump in the instantaneous flows in the system.
Well, just because you increase the pipe size and the flow, what it can carry, doesn't mean that more toilets are going to flush in the future, does it?
No, it has everything to do with wet weather. That's all being driven by wet weather flows and how quickly the collection system can move those wet weather flows that are getting into it to the treatment plant. So while it says 2040, those improvements are likely going to be done before that.
Right now, portion of the collection system is acting as storage or detention, so it's slowing down the flow. So as we open that up, we'll get higher instantaneous flows.
Still the same volume, but it's just how it gets there.
On the next page, page 9, talks about the maximum hourly flow for the Brine pipeline. It's based upon the maximum hourly flow seen at the existing WWTP. What brine flow is coming from the existing plant?
There is no brine flow from the existing plant. That brine line that we're going to be, we're calling it the brine line, so during dry weather flows, when the advanced treatment facility is operating, essentially 100% of the flows will be going through the advanced treatment system. And 80 MGD will be going, or 8.8 MGD, excuse me, will be going out to the potable injection, and 0.2 would be going into the brine line. The problem is that we need to have the ability to send all of the flow out to the ocean outfall if we need to do that. One, if we have high wet weather flows and the advanced treatment facilities aren't operating. So it's doing dual duty, that this disposal line. It's not only for brine, but it's also to carry all of the wet weather as well.
And it'll plumb into the outfall?
That's correct.
Being that we're not producing brine right now at the plant, I know we're producing some brine at the water treatment plant, but the proposed wastewater treatment facility at South Bay, that brine, will it not have constituents like pathogens and viruses in it as well? That'll go with it?
That brine would still be disinfected, so that brine will be treated to the level required by the city's NPDES permit. Those requirements are identified in the time schedule order, essentially, so that'll have to meet those requirements.
So there'll be a treatment for the waters going in the IPR line, and then treatment or chlorinization that will go into the brine line?
That's correct.
Okay. A couple errors in there, or typos. Top of page 11, it says something about error, reference, source not found. I don't know what that means. I don't know if you guys saw that, if that means anything. On page 12, figure 1.3, it has shows the west line, best I can tell, leaving the state highway right away and entering back into Lilac-Heiser Park before it crosses over Moore Creek. But back on May 9th, I asked, is it going to cross Moore Creek in the state highway right away? And Rob said, yes, it was. So where are we going? Where is it going to be?
It's not crossing in the state highway right away.
So before it gets to Moore Creek, it jumps back into Lilac-Heiser Park?
That's correct.
I was in error.
Oh, okay.
Yeah, that just to clarify, that hasn't changed. The concept has always been, well, since the development of the 30% design, was that we would be using a pipe bridge to cross Morrow Creek.
On page 13 on that table 1-3, you compare the other alignments identifying fatal flaws, but you say on the east alignment, environmental for drainage lines and wetlands would require separate environmental permits. Won't the west alignment also trigger those same environmental permits? 1601 agreement with the Fish and Game and 404 from the Army Corps of Engineers?
We don't anticipate a 401 or 404 with the regional board or the Army Corps. We're not impacting, at this point in time, we're not impacting any jurisdictional waterways. Again, that is something that we're looking at in the EIR addendum. We had to do some additional delineation work in the area of the bike path, but the current plan is to be able to cross those using trenchless methods so that we're not impacting them.
On page 28, you talk about some complete final studies and field investigation. One is to prepare a draft Caltrans encroachment permit. We haven't started that?
The design engineer is currently preparing that draft permit.
the design, the waterworks,
Waterworks, correct.
and that'll go to District 5.
That's correct.
Does headquarters have to have a say in any of that?
The value of the construction that we're currently planning to do in Caltrans right-of-way does not exceed the amount that requires it to go to Sacramento.
Do we have anything in writing from District 5 or Sacramento that says that District 5 can issue it without an exception from headquarters?
I do not know if we have any, no, actually.
Only the meeting notes from our meeting with the District 5 permits engineer.
Okay, I'm going to jump to page 44. You have the different type of pipeline materials. And I was wondering if you guys considered welded steel pipe. You can get a lot more production with welded steel. It's 40-foot lengths. You go twice as fast. You put twice as, and get out of Quintana Road that much quicker.
The analysis that was done, it would be less expensive to do HDPE or fusible PVC. I also believe the production rates would be faster with that type of construction versus welded steel.
On the high-density polyethylene pipe, if you fuse that, you do that above ground and then weld it into the trench, is that how you do it?
That's correct.
And how much can you do in a day on that?
Likely, that'll vary depending on what part of the alignment we're talking about. We're going to be putting constraints on the contractor that they can only have so much trench open at any given time in order to maximize the ability to minimize the impacts to traffic flow down in the more sensitive areas. In the less sensitive areas, and we'll put less constraints on the contractor, but that's something that's going to be, in the sequence of work, is going to be very detailed.
Will any of these pipes require thrust blocks?
I don't believe so, since the joints are restrained, since they're fused.
On page 49, you show the different configurations, or start to show the different configurations of how you're going to put these pipes in a single casing. And being that each one of them is going to have its skids around each pipe as you slide them through, push them through. I've never seen multiple ones put in the same casing. Will that all go in at the same time?
What page was that again?
It's down on page 49, and then the next page has the different configurations of putting multiple pipes inside the casing pipe. And so in my experience, you strap the skids around the pipe and then you push it through. But I've never seen multiple pipes done at the same time. In other words, if you put one in and it's got its skids and its bands around it, you try to slide the next one, it's going to hang up. They all have to probably go in unison, it seems. I mean, I don't know, did somebody think about that?
Yes, and we don't have anybody from Waterworks here to speak specifically to that, but we can get you some details on that.
The casing pipe that runs in the state highway right-of-way will have to have a certain amount of cover on it. And how far down will this thing be, the bottom of the trench? Because the exhibit on page 49 has a 54-inch diameter welded steel casing, which the other pipes will go inside of. And then there has to be a minimum cover over that. So we're down, what, 7 feet?
The concept is that pipe and the casing would be put into the shoulder there on the slope of the road. I don't have the specifics in terms of the cover. Again, I can get that for you from the drawings, and I can get with Waterworks and get that information to you.
Doesn't Caltrans have a standard for cover?
They'll likely have a minimum cover requirement. I'm not familiar with what that is versus in the roadway or the shoulder, but again, I can get that to you, and that information is going to be detailed in the 60% design as well.
On page 54, you talk about these different valves, but are there any inline isolation valves in any of these lines?
Again, that'll be details that are included in the 60%. I believe we do have some isolation valves throughout the system. We have a number of air release valves as well. One of the things that we're currently working on is the surge analysis for both the raw wastewater force mains as well as the brine or effluent disposal line.
On those isolation valves, do you anticipate using butterfly valves?
It would depend on the service. We typically don't use butterfly valves in any raw wastewater applications because you have an obstruction in the flow path. So typically we'll use either gate valves or full bore eccentric plug valves.
Page 61. At the top, it says something about 5 to 6 feet of cover. It says COER, it's a typo. But down below, it starts to talk about the utility conflicts. If a utility has to move out of the way of this project, who pays for that?
I think it depends on what utility it is. If it's the regulated public utilities, they exist in city right-of-way at the pleasure of the city, and we would direct their relocation.
In my experience, that if you're acting as the road department, you can do that. But now that you're acting as another utility, the cost is borne by you to do that, to have them move. It's my experience. We had to do the Shore Valley Pipeline. We had to pay for any relocation, even if it was in a county road. Because it's not the same, we're not wearing the same hat.
Okay, we'll keep that, make sure that we're wearing the same hat.
Page 63 starts to talk about the outfall constraints. And then the exhibits, in the sheets, the plan sheets, show how you might plumb into that. Where is that outfall, and particularly that standpipe, relative to the state's original jurisdiction? Is that where we're triggering their involvement?
Yeah, the air relief structure is located inside the plant fence line. It's not
Right.
within the original jurisdiction.
It's not? Are we doing anything, where is the state's original jurisdiction? The ocean?
Westward of the first public road, so just on the other side of Embarcadero Road, there is their jurisdiction. So we're having to do modifications to the outfall itself, change diffusers, because there's a different constituency of the wastewater. So we'll be replacing and changing out diffusers on the existing outfall.
Where are the diffusers, in the outfall?
In the outfall at a mile offshore, so.
You add air into the line, is that what the diffusers do?
The diffusers are basically outlets. It's not an open-ended pipe that just discharges to the ocean. It's pipes that are tapped into the side of there that disperse the wastewater along a section of that pipe.
Like a manifold, or?
Like a manifold, exactly. And we'll be changing those to more of a duckbill style diffuser.
On page 66, a couple of things here. When you're going up South Bay Boulevard underneath the structure, the highway overpass, you're not required to have a casing there? Like everywhere else in state highway right away?
Repeat your question really quickly. I was looking at the document here.
Casing under the state right away in South Bay, is that required?
The plan does not currently have a casing for that crossing,
Okay, and you're
that
gonna,
buried crossing.
and you're gonna open trench through there?
That's correct.
How are you gonna get an excavator in there, open up an 8-foot wide trench and without hitting the superstructure above?
And that's, that's really why we initially, the assumption was initially made that we would be going with the trenchless across Highway 1. But the design engineer, as part of the concept design report reviewing that, determined that was something that could be done.
if you open, because you gotta use up all the room to put your piping ready to put in the ground, stockpile it on the side or put it in a waiting truck, and then put it somewhere in the middle so you don't hit the abutments of the structure, you've effectively closed down that interchange. Now, as I recall, in the environmental document, at least the addendum that you're gonna do, ESA in their proposal was not gonna do additional traffic studies. However, the original traffic studies in the area never anticipated this. So how are we going to identify this impact that's going to occur at that interchange when the off-ramps and on-ramps are closed?
We can talk to ESA and get back to you on that exactly, and what kind of impact that might have, and if that's something that we need to include in the addendum.
Because it seems to me the only logical detour, if you say you're coming home from San Luis, can't get off at South Bay Boulevard, you have to go to Moby Boulevard, probably to Piney Way, to down to the state park. South Bay Boulevard has over 15,000 cars a day presently. Can we put that amount of traffic on the city streets and the state park road without damage?
We'll have to look into that and get back to you.
The other item you have on that same page is that night work may be occurring for the South Bay Boulevard. You have a sensitive noise receptor there, the Casa de Flores. Is night work acceptable for being that close to that facility?
That's one of the things that we are working through is the sequencing of the work and the traffic control requirements that are going to be required. We're going to be coming back with a lot more detail on that for the 60% design.
On page 74, tabled 4-9, you talk about the Mole Creek crossing, and particularly a new pipe bridge. Do you still require, even though you're not in the state highway right-of-way now, do you still need some easements from, like, PG&E or whoever owns that land that you're touching down on? The one, the Exhibit B, I think it is, has the right-of-way maps. It looks like that's PG&E property.
There are several easements that we're going to need along the conveyance pipeline. I don't have the specific one in front of me, but I can get back to you on that as well.
So with the trouble we've been having with PG&E, is it possible we're going to run into difficulties getting easements from them?
The problem has not necessarily been with PG&E. That's been more of a timing issue and just the length of time that it's taken to coordinate some of the activities. The other property owners have been a little bit more difficult. But again, we don't anticipate that being an issue. We're tracking all of those easements and working on those currently.
Do we have any idea what it's going to cost to acquire those easements?
All of the cost for, our estimate for the cost of all of those easements is included in the cost estimate for the project.
The pipes and then that pipe bridge, they'll be above the 100-year flood elevation at that point? They'll be suspended in the air?
Yes.
Then when you get a little bit further south, just before you get into the Main Street area, you're on the bike path where it's concrete. You cross the Willow Camp Creek there, and there's definitely a wetland there. There's no mistake. So I don't know how you can avoid the 404 permitting process from the Corps at that location.
That's the area where Eric was talking about. We would do trenchless through that area.
On page 80, you talk about the jack and bore, and different types of casings. In my experience, there's a minimum size casing that you'd want to put in just in case you have to enter into it. Has that been addressed? For instance, when we bored underneath Highway 1 at La Loma, immediately they encountered a rock in Quintana Road, and the thing was deflecting. And they couldn't get in the casing because it was too small. They would have jackhammered it out. So they got a permit from you guys, came down, dug up a big hole in Quintana, took the rock out, and then continued boring through. So there's a size of casing pipe that can't be entered into in case you run into a boulder or it deflects. The guy said that if he ran into solid rock, he could drill a hole through it. But when he hits a boulder, which you might find out there, you have this problem, deflecting. So the casing size has to be big enough so a man can enter and jackhammer out the obstruction.
Again, that's something that we can discuss with the design engineer. I think one of the things, one thing that will make that question a lot easier to answer is once we get the geotechnical information back, we can understand what the likelihood of hitting boulders or cobbles might be in those different areas and then take that into consideration.
On page 89, you talk about high groundwater. And I know this would be a problem for your trenchless crossings, but even open trenching like down the bike path, you're certainly going to encounter high groundwater. How are we going to handle that as we trench through there?
Again, there's a couple of different things that we're doing there. We don't have the geotechnical information back, which it's difficult to answer a lot of these detailed questions without that. And we're also looking at getting some groundwater monitoring data near some specific areas in the alignment to identify what those fluctuations are and if we can plan our construction to try to minimize the issues of the high groundwater. But we know it is something that we're going to have to deal with, and it's something that we'll detail in the 60% design again once we have the geotechnical information.
So you have to put up coffer dams and constantly pump as you move through that zone?
We have not planned exactly how we're going to be handling that. Once we have a better idea of what those levels are, then we'll be putting together those dewatering plans.
If you have any dewatering, where are you going to discharge the water?
Again, we'll know more once we have the geotechnical report and how much water we need to deal with.
In previous projects where we've had to dewater, for example, for wet well construction, we've applied for and received a low-threat discharge permit from the regional board for that dewatering water. I've had success also putting rock in the bottom of trenches to, depends what the depth of groundwater is.
Your report, I don't know if you're going to get into it now, but we have these appendices that were attached to the report. Appendix A, that shows a line for the conveyance pipeline path. Right now, it just on the paper, on the drawings, it's just a real fine line. I don't know if that's the center line of a 12-foot wide swath. It'd be nice if that line really was that width, as it shows how that path and what's going to be disturbed in that path, rather than just a fine line of the actual width.
It will be, for sure, for the 60%. There's going to be a lot more detail in terms of the plan and the profile detail.
Is that line the center of the 12-foot trench?
I believe that line is the center of the 12-foot trench without having it in front of me. Which, you said Appendix A?
Right. Then Appendix B is your right-of-way exhibits, and they label the freeway as US Highway 101. I believe it's State Route 1. Is it not?
It's not 101.
Okay. Appendix C, I believe it's on the plate 1B, if I could find it. It has that route shown here, much like what Valerie was mentioning as I'm going through the ball fields. And this is the Geotech report. So are they looking at a different route than we're seeing in the concept report? Is the Geotech people studying the right area?
The Geotech report was developed, this is the preliminary Geotech report that was developed to support the initial planning effort for the project, the environmental document and those things. There's a completely separate Geotech report that's being done. The final design Geotech report's being done currently. or it will be done soon, as soon as we can finish the underground investigation.
Then in Appendix D's, it has some more plan sheets. And the first one below, it shows the proximity of the city wells at Lilac and pipe to the alignment. And that we're like about 25 feet out from the wells. Is this the reason that we moved over to the state highways to avoid the wells? And not the cultural resources?
No, the reason was to avoid the cultural resources.
Is there a distance that we must stay away from those wells?
I believe the distance is 50 feet.
So you'll be within that 50 feet?
We have a plan to mitigate that. I don't recall exactly what that is off the top of my head, but it was something that we looked at when we made the decision to realign the pipeline. So the realignment of the pipeline was done at added cost to the project, so that was not something that was, it would be less expensive and easier to go through Lilac-Kaiser Park. But again, because of the concern from the Native American groups, the decision was made to move it, and we do have some challenges in avoiding those wells, but the design engineer does have a plan for that.
Do we suspect there'll be more cultural resources underneath the freeway? I mean, there's what, this whole area dates back, what, 9,000 years? I mean, there's been several occupations and millennial periods of occupation in this area. I can imagine before the freeway and before Portola even showed up in this area that it was all utilized.
Yeah, the archaeological study that was done to support the environmental document found a number of cultural resource areas. We're doing some supplemental archaeological work to support the addendum. Again, it's something that we're going to be monitoring for, and we'll have a plan to deal with if we do encounter it during construction.
I think the only saving grace there is most of it is fill that we'll be working in the, where we're in the Caltrans right away, adjacent to the bike path.
With the dimension of that casing being 54 inches and needs to recover, and I think you're going to break down below the original ground of the freeway, you'll be in virgin territory. And my experience, like when we do the Troll Valley pipeline, you won't find this stuff on the surface, but when you dig down, oh boy, it's there. It's everywhere.
And we'll have monitors all along the pipeline route. I'm sure there'll be something encountered somewhere where we don't.
Well, I guarantee you you'll find something. Okay, that's all the comments I have right now. I don't know if anybody else had any more comments to make right now. Valerie?
Excuse me.
Go ahead.
Just one comment. That's part of the development, what the consultants are going to be working on, the cultural resource consultants, is a treatment plan for discovery during construction, and that's all part of the agreement that they'll be asking for concurrence on from the SHPO. And for exactly that reason is because it's not accessible. I know when I worked for the highway department, we had projects that were not accessible, and we had to defer certain kinds of work to later to construction or monitoring and plan for discovery during construction. So,
I'm not sure I understood it correctly when Paul was going through this, but my understanding was the alignment was going to be on the on-ramp and off-ramp to get over to Main Street. Now I'm hearing that you have to create a pipe bridge over the Morrow Creek crossing. That means you'll be out of the on-ramp and off-ramp coming, I guess, to the west to make the pipe bridge. Why can't you fit above the culvert that Morrow Creek goes under the creek? Is there not enough cover between the pavement surface? Am I making sense? I'm assuming the on-ramp and off-ramp are built over a culvert for Morrow Creek to get under.
They're bridges.
What is it?
They're bridges.
Oh, they're physical
You can't
bridges.
put
Okay,
them
I'm
up.
sorry. I thought it was a culvert.
Caltrans
Okay.
won't allow it.
Oh, okay. That answered my.
Yeah, there's no capacity on the existing structures.
I got
for,
you. So you'll have to make a separate pipe bridge to the west of the edge of the bridge. Okay, thank you.
Doug, do you have any questions? Okay, with that, I'd like to open it up to the public. If anybody from the public would like to talk to this item, it's time to do.
Committee, Barry Brine, Morro Bay. The challenge of designing what you've done is enormous. I think it's made doubly enormous by the fact that we have not repaired any pipes, and we're looking for more infiltration into the existing pipelines. And it appears to me that this would be a prudent time to say, look at, we have these things on our capital improvement budget, and rather than basically hold back the money so that you'll look good for the lenders, it appears to me that it'd be more prudent to get at some requests for proposals, repair some of these pipes. So I know that you're using now, because you have some constraints in the pipeline, that when all that stormwater comes in, you're allowed to keep the water back so that you can bleed it through the plant in a proper manner. But if you didn't allow all that infiltration, and it's pretty well identified throughout the system where the problems are, you could mitigate a tremendous amount of this design work, and extra pump sizing the plant, how much you're going to have to put back in the ocean. And I don't think that, to me, it's most obvious to solve the worst problem first, and that's the infiltration. This talk about wet weather flows, I understand it's reasonable wet weather flows, but when you're talking about wet weather flows of making the plant volume go from 1 million gallons a day to 8 million gallons a day, that's such an increase in wet weather flows that I can't believe that we haven't at least, we've talked about it, I've asked the question, I'll ask it again, but unless someone faces the fact that we have large amount of infiltration coming into the plant, which costs all of us taxpayers more money because the plant has to be designed so much bigger because these pipes are leaking, that's just not a prudent use of our money. Thank you.
Thank you, Barry.
Thank you, Council. Larry Truesdale, citizen of Morro Bay. I have 3 questions. Some may have been answered before, but I have not been participating in it. But I have not seen any correction in the volumes of these flows for the departure of Cayucas from our system. It may have been done, but I've never seen it or heard it talked about. When will we correct for that in our flow calculations? Next question is, what is the lifespan of this HDPE piping, high density polyethylene, versus say the stainless steel? Next one is, if stainless steel pipes get us off Quintana in half the time, the differential in cost between the stainless steel and the polyethylene, is that sufficient to penalize the businesses there who are going to be severely impacted? The economic comparison of all this, I don't have numbers, I have no good in order of magnitude. But the lifespan of polyethylene means at some point, polyethylene is not a hard thing. It will move over time, and it will be impacted by the external environment. It will have to be replaced. I suspect the stainless steel goes in there and it's protected against galvanic corrosion will last 5 times as long. I have no idea. So in doing the economics of whether it's polyethylene or stainless steel, I think I'd like to see that put together so we don't wipe out businesses on Quintana.
Thank you, Larry. Anyone else from the public who'd like to speak? Seeing none, I'll return it to the committee. Would staff like to answer any of those questions?
We have 2 projects in our capital program for this upcoming year to begin the Beachcomber area and then the Main Street of Tesco Road, 2 of our worst areas. So we'll be going out for design this year and likely construction in following years for that work. My experience with I&I is it's a never-ending battle. You don't fix a collection system one time and it works forever. It's a continuous process that what we continue to do. We repair manholes, we fix lateral break-ins. It's not just one problem, it's a multitude of problems. We replace manhole lids with sealing manhole lids. So there's various reasons for I&I. Pipe material, first Cayucas flows, those are not included in the One Water plan, the facilities master plan, nor this design. It's all Morro Bay flows. Pipe material, I think Mr. Truesdale must have meant welded steel pipe, not stainless steel pipe. Production rates for HDPE versus steel. I would think, my experience with HDPE, fortunate enough to work on an HDPE project where there was no constraints. We put a mile of pipe in the ground a day. Probably not the case here, too many crossings, but it is possible for high production on HDPE pipe. I would say that the life is fairly similar between HDPE and steel pipe. All pipe is going to move in the ground. I think what you rely upon is the method of placement. So your properly engineered backfill, compaction, monitoring of the trenching requirements, that's really what protects the pipe, not the pipe material itself. I'll turn it over to Eric, see if he has anything else to add.
When you put in that, either the PVC or the polyethylene pipe and use that, and you'll do a pressure test, is there allowable loss during that pressure test for that kind of pipe material?
I don't believe so. Can you allowable pressure loss?
In other words, you do a pressure test on a water line, for instance.
Correct.
And you pump it up for so many hours and watch it, and there's an allowable loss in that period of time. If it loses more than that, then it's not acceptable.
Correct.
So is there an allowable loss during the pressure test of these pipes?
It would be tested to the same as a steel pipe.
And no allowable losses?
I have to go look at the testing requirements. Yeah. It's AWWA standard that we would look at. I don't know that off the top of my head what that allowable loss is.
The losses are going to occur not at the fused joints, but at the, probably the, if there's any mechanical joints in the system, rather than the fused joints. Where I've seen failures in HDPE pressure testing is at those mechanical joints, having inadequate restraints and having fittings blow off, but never have seen a pipe failure due to pressure testing. It's at the field installed mechanical fittings.
And what is the pressure of these pipes? I guess your force mains will have the highest pressure, they have the highest lift. 200 PSI? What?
Probably somewhere in that range, 200, maybe up to 250 PSI.
And then you have pressure tested to, what, 125% of that?
Likely. I can't remember what AWWA standards are. I have to look that up every time.
Okay. Also on the I&I, I know that it was something that Joe's predecessor, Bruce, told me, is that a lot of people have plumbed their downspouts into their laterals. Is the city doing anything to keep that from entering the system? Do you know anything about that, Joe?
Yeah, we identified a lot of the high I&I areas, and every year we go out and smoke test those areas. And when we smoke test, we can find a lot of that if they tied in, their downspouts, their driveway drains and stuff like that. And then we send letters to those residents, and I can say since I've been here, we've done 2 rounds of smoke tests, sent out the letters, and then we follow up and had very good response from the community actually fixing those and addressing those issues right away. So
Good.
We had very good response.
Good, good. Okay, I believe that's it for this item. Does the staff have any more to say on this? the staff recommendation is to accept the final draft concept report and provide comments? Or are we supposed to speak to the groundwater modeling item before we finish this item out?
The plan was that we would get through that first part, and then we would do the presentation for the groundwater modeling item, and then go through discussion at that point.
Okay, so you want to continue with that then?
I've got a question before we move on.
All right.
I'm reading over this report that Larry Truesdale presented, and, he's talking about contamination of the wells with human waste. So I think it's time to, could that be addressed? I mean, it just seems, I haven't heard this before, and since we're talking about infiltration, I mean, Joe just mentioned the smoke test and all that, but is this really possible?
We can address that a little bit. There was, in Mr. Truesdale's letter, he did reference a report that was previously done by another hydrogeologist about that, and we can reference that once we go through our presentation.
Okay, because I noticed that in the GSI report, one of their references, of course, is Cleeth and Associates, March of '94, and Truesdale's mentioning Cleeth and Associates 2007. So, but I don't see that in the EIR. So I'm just puzzled as to, it'd be nice to just address this finally, because I hear these sorts of things and I don't know what's the truth here.
Yeah, we can talk through that.
Okay.
So you want to give your presentation on the groundwater modeling now?
Yeah, I can run through that quickly and then we can get into discussion.
Came in city email. It came in this afternoon. I just have to check it and something.
Okay, thank you.
The last minute.
So just a quick summary of the hydrogeological activities that are required to complete this project. It's really a four-step process. The city has been working with GSI for a number of years now. Their most recent report was one that was developed in 2017, the feasibility study that looked at the feasibility of injection of purified water into the lower Morrow groundwater basin. And then following completion of that report, the city put out a request for proposals and subsequently selected GSI to participate and perform the next 3 phases of hydrogeological work that need to be completed. And we'll go through a little bit of those here today for the focus on phases 1 and 2, which is what GSI is currently contracted to perform. And obviously phase 1 is what we're discussing here tonight for the technical memorandum. So we're really looking at the feasibility study, 2017, phase 1 of the geotech work, phase 2, phase 3, and that's what will position us to do the final design of the injection facilities, or what we refer to as the recycle water facilities. So the feasibility study made a number of findings. One, that the aquifer, it's feasible for the aquifer to accept injection. Number 2, a minimum of 4 injection wells will be needed to inject the quantity of water that we're looking at. We're looking at a range of capacity of that basin to accept the water. The determination was made that approximately 1,200 acre-feet per year of groundwater could be produced and be injected using IPR, and that the minimum 2-month subsurface retention time could likely be met at both the west injection location and the east injection location. So the phase 1 scope of work, again, what's covered here in the technical memorandum was 1, to investigate pumping of the city's full permitted allotment of 581 acre-feet without injection, analysis of possible groundwater nitrate levels under different injection scenarios, and then analysis of potential changes in groundwater chemistry due to potential saltwater intrusion. So really the first item, looking at the city's ability to pump its full allotment, that was really something that was spurred out of the development of the One Water Plan and looking at a number of different water supply options that the city has in front of it. And if really truly could the city Could the city pump this full 581 acre-foot allotment from the Morrill groundwater basin and not induce any issues in terms of water quality? The next two really do with what happens to the water after it's injected and extracted. Is there any follow-up treatment that would be required? The approach for phase one, on the right you'll see a figure which pretty clearly shows the lower Morrill groundwater basin. The contour map that's shown there. Some of the notes that I wanted to highlight here is that pumping data between 1965 and 2018 from 7 different wells is what was used to create and calibrate the model. TDS, or total dissolved solids salinity, and nitrate data was available back to the early 1980s, and it's for different periods for different wells, but the oldest data goes back to the early 1980s. And the city was building, or excuse me, GSI was building on their existing mod flow model. So that's their groundwater model that they developed for the feasibility study. They have an add-in for mod path, which essentially does particle tracking in the groundwater. So they take their existing model and they layer in this additional capability with ModPath to do the particle tracking for constituents like nitrate and TDS. This is just a graph showing the historical pumping from the lower Morrill groundwater basin, and as you can see, the groundwater pumping is reduced significantly with the city state water coming online here, and I just wanted to point that out briefly for the way that the city's current system operates. So the first task was to look at the impacts of pumping on seawater intrusion. So the city has a permit to be able to extract 581 acre feet per year from the Morrill groundwater basin, and currently the city only extracts a fraction of that. The majority of the potable water comes from the state water project. The city does extract groundwater during periods of high demand during the summer or periods of outages for state water. So we first asked ourselves the question of, well, could the city decide to just start pumping the groundwater basin in the absence of state water, or if it wanted to more highly utilize its existing groundwater basin, what would happen under that scenario? And so the scenario was run with pumping of the 581 acre feet allocation. Looked at a simulation lasting about 38 years, starting from now and going out 38 years, and it identified that the TDS concentrations over that time would get into the range of about 5,000 milligrams per liter to 17,000 milligrams per liter. There's a footnote here at the bottom. TDS, or total dissolved solids, are not a primary drinking water MCL. They're what we term a secondary drinking water MCL, and the limit for that secondary MCL is 1,000 milligrams per liter. So what we're really trying to say here is that the city really is at risk of pretty significant seawater intrusion if they were to increase their groundwater pumping. So if the city just decided right now that they wanted to just pump that 581 acre feet from the Morrill groundwater basin over a not too short period, and start seeing seawater intrusion. So that was the first element of the phase one work. The second and third elements of this work really looked at not just extraction, but the combination of injection and extraction. And it should be noted that as we discussed earlier with the conveyance facilities project, we're looking at 2 different injection locations, and we're carrying forward those in the environmental document and continuing to carry those 2 options forward to give us the most flexibility for when we decide to start the final design of the injection wells. And so those are two different injection locations. One is over on the west side of Highway 1. We've been terming them the west injection area. GSI in their report refers to it as the south side injection area, and then the east by Silver City is, we term the east, and in their report is referred to as the Narrows area. So first looked at the impacts of injection on nitrates, and so using historical data, historical nitrate data. The model was calibrated to that nitrate data, and you can see here, the red line represents the primary MCL for nitrates, and in that red line, under a series of injection of about 825 acre-feet per year. Again, the designed injection capacity of the existing wastewater of the new water reclamation facility, and an extraction at the city's permitted extraction capacity, 581 acre-feet. It was determined that the nitrate concentration in the groundwater would drop below the primary MCL. So that was really the big question that we wanted to ask ourselves is what will happen with the nitrate concentration if we were to inject and extract. One of the things you might ask yourselves is, if we're injecting 825 acre-feet into the ground, why are we only extracting 581 acre-feet? The reason why the analysis was done in this way, and we're continuing to do additional groundwater analysis, is that we had an even comparison with the non-injection option. So we're extracting 581 acre-feet without any injection. So what happens if we extract 581 feet with injection? And so that's why the decision was made to run the model at the 581 acre-feet extraction. Now we're going to be running a number of different model runs in the phase 2 work, and we will be looking at different extraction volumes and injection volumes. So the next question is, what is the impacts of injection on salinity? And I apologize that the heading here is incorrect. But again, the model was run with no injection to look at the TDS concentrations. Again, this line here, this orange line, shows the secondary drinking water MCL for TDS. And again, in this scenario, both at the west and the east injection locations, with injection and extraction, you see the TDS concentrations below the secondary drinking water MCL of 1,000 milligrams per liter. That should not say 45 milligrams per liter. The orange line is correct. The call out is not. So that was that's essentially the takeaway from the phase 1 work is the phase 1 work was very focused in looking at what are the impacts of these different constituents in the groundwater under different scenarios, and we're currently working on the phase 2 work as we speak. The phase 2 work is really focused on, again, building on some of the information that we learned in phase 1. But we still have a lot of work to do, and GSI is currently working on a number of different items. So phase 2, what we plan to complete over the rest of this calendar year is really looking at design and permitting of the test wells. We're currently working on that. Really evaluating the 2 potential injection well locations and figuring out what is the preferred area for injection and testing. Securing the permits for the injection testing wells, conducting the actual pilot injection testing and doing any tracer studies or anything that we may need to do. As I mentioned, we're going to be continually updating and getting better information into the groundwater model. And then it really leads us to the big payoff as it pertains to the permitting aspect of the project with DDW, which is showing that the travel time can be met with the travel time analysis and a clogging analysis of the injection wells. And then continuing to perform seawater intrusion monitoring and groundwater level monitoring. So what are we currently working on right now? What is the team currently working on? Phase 2, status update. What are we currently doing? We've working on the evaluation of the injection location, specifically when GSI started and when they prepared their proposal and when they negotiated their scope of work. There were some concerns about the geology in the Narrows area or the east injection area and the ability of that area to be able to accept the injection water. So as a way to identify or help identify if that was going to be a possibility, some cone penetration tests were done in the east area within the last couple of months. That's come back favorable in terms of the ability to inject in the east area. So that work has been completed and allows us to continue to move forward with analysis of the east area. That was kind of a pass-fail. It's a fairly inexpensive geotechnical investigation that can be done, and so that work was done, and it allowed us to say, okay, this makes sense, let's proceed down this path on the east area. We're now currently preparing the test well design and permitting in the east area. We're preparing to install a piezometer on Arrow Street. We're currently looking at that being done as early as June 13th of this month, or the 13th of this month. And then as a part of that exercise, we're also working to get a firm online that can help with the pump testing for MB13. So we'll use that pump, the pump testing data and the piezometer in tandem to better identify what's going on with the boundary conditions for the east area. And then on the west area, we're working with our partners at Vistra. Again, as I mentioned, we've been working and have recently gained access to the site for a number of different activities that we need to perform there. One of them being the hydrogeo work, and we just sent over today to Vistra our work plan for what we want to do on their site and potentially with some of their existing infrastructure. And so we are currently working with them on that. In terms of the seawater intrusion monitoring, back in December of last year, GSI installed some pressure transducers, sorry, I lost my train of thought there, some pressure transducers in the city's existing seawater wells. And those are also used to monitor the water quality in those wells, as well as some pressure transducers were installed in the city's existing production wells. And so on multiple times a day, the city is getting information back on the groundwater level and the groundwater quality as it pertains to total dissolved solids in those wells. So that effort started back in December of 2018, and it will continue through the implementation of this project. Again, that's again an overview of the phase 1 work and a preview of what we're doing currently doing in phase 2. Again, what we're asking for you tonight is to again accept the final draft concept design report and then provide comments on the presentation that we just presented on the phase 1 work.
All right, thanks, Eric. Does the committee have any questions? I'll start with you, Steve.
Okay. I feel somewhat remiss, Eric, because, like I said, I was reading this off an iPhone. I was out of town. And when I read the actual staff report, it talked about only accept the final draft concept for the waterworks engineer. And then it says, and provide comments and inputs. So I kind of pushed all my energies into looking at the waterworks engineering report. While I can make some comments off what I saw today, I'm not quite sure I feel in a position to accept it since I really haven't had the opportunity to go through it at any length. Is it only getting approved at each phase, or are you looking for something at the end of all this after the other phases are done? I'm not sure where you're going with city council after this. Are they also going to try and accept this final report?
I believe we're just going to be looking for the council to receive it and to review and receive and provide any comments. I don't know if there's anything in that report that needs to be kind of formally accepted by council. Okay. It's really just a continuum of...
Yeah, I read one that sounded like you're looking for an approval, and the other one I felt like it was purely comments.
Yeah, this is really, this phase 1 and phase 2 and phase 3 work, it's really just a continuum, as every time we're continually getting more and more information. We're adding to the groundwater model. We're doing more and more field investigations. At some point in time in the near future, likely what the option would be that we start to veer away from one of the injection locations and start to focus more of our effort on the other as we start to learn more and more things. Now, we haven't seen anything that kind of puts the death nail in either one of the injection locations, and so we're still kind of proceeding down the parallel path. That was the point of the geotechnical work that was done a couple of months ago. Very likely could have, 2 months ago, we could be here talking to you today about how we're no longer pursuing the east injection location because of something we might have found there, but we didn't find that, and so that's why we're still kind of continuing down that, both of those
Okay.
paths.
Well, on the question side, most of it came up as a result of looking at the different PowerPoints, was on the modeled injection well locations where you show the west, south side ones and then the ones up east in the narrows. It's your intent only to do one or the other, not both, is that correct?
We're leaving both of those opportunities on the table, and really, again, the linchpin in this is DDW's confidence in the travel time. It's really the emphasis is all based on, DDW's sole mission, and really our sole mission with this is the protection of human health. So, that's what they have very rigorous treatment requirements they've identified, and then really the point of the travel time in the groundwater basin is to be able to give a reaction buffer if there was something to happen, which is why they require the minimum of 2 months, and it's more nuanced than that based on what we actually see in the model, the level of rigor that we need to go to prove out what our actual travel time is before we start up the facility.
So in this particular example you showed here, I assume the little yellow wells are where you're actually going to extract the water?
Those are the city's existing extraction wells, that's correct.
And so with the east narrows, it's basically, it filters down to those wells, since I assume the gradient's going towards the ocean. With the other, is it just backwater? The ones on the west side, is it backwatering up to those wells? Is that how the hydraulics, so to speak, work?
I have Mr. Nate Page here from GSI, if he wants to.
Oh.
He can answer some of the more technical hydrogeological questions.
Oh, okay. Yeah, I just want to get my head wrapped around exactly how the flows work. Hi there today, thank you.
Yeah, Nate Page with GSI.
So basically, the west-south side, are you creating a high enough gradient it backflows towards those wells? Is that the
Yeah,
intent?
that is how that would work.
Oh, okay, and then the other, I assume
mound.
it's just the natural gradient coming down from the east narrows?
That's correct.
Okay. And then, I think that was the main question I had, and how all this worked at this point. Like I said, unfortunately, I did not get enough chance to truly study it, because I thought it was an ongoing matter, the way it was worded in the staff report. So thank you very much.
You're welcome.
Oh, go ahead, Valerie.
Actually, can I ask him a question while he's here? I didn't realize. You're finished, right?
Once he gets exercise.
The modeling that you did in regards to saltwater intrusion and its impacts on the groundwater, the aquifer, I'm wondering, you're looking at historical information and existing conditions and what have you, but I didn't see anything in the report that takes into consideration sea level rise. And I know that we're not the Bay Area, we're not San Francisco Bay, and in terms of all the detailed modeling they've done up there in regards to sea level rise and saltwater intrusion, but are you going to be including any projections in your future work and how that might affect this whole discussion in regards to injection wells and
Yes.
injection sites?
Yeah, that'll be done in the phase 2 portion of this work.
Okay, do you know what level, are you going to use a suite of potential levels of sea level, as opposed to taking the most conservative and going with that and saying, well, in 50 years, it's just going to be
Yeah, I don't
half
know
a
the
foot.
specifics at this point, but I'm sure that we will not use just the minimum
Okay.
considered likely.
The city has an adopted climate action plan, so we would want to make sure that any analysis that we do is going to be consistent. Consistent with that document. I don't have that document
Which,
offhand.
I don't know if the climate action plan is a living document. I know that the projections are changing, and so that's why I'm asking if we're going to be looking at a suite of potential levels of sea level.
In addition to the climate action plan, the general plan analysis included an LCP update, included a review of sea level rise and its impact on land use and the city of Morro Bay, how we will develop in the future. So we'll make sure that we're also consistent with that document.
While you're still there, just real quick, before I nip to Doug here, but on that sea level rise, will that make the west side less favorable than the east side in time? Would it have that effect?
It could potentially decrease the holding capacity of the aquifer, but the west side uses an injection point, could actually create a mound that would, act as a seawater intrusion barrier. So it's difficult to say at this point. We have to carry out the phase 2 work to, and better understand the aquifer to truly answer your question.
All right, I was just curious. Doug, do you want to say something or ask any questions?
Thank you. On this figure 6 that we looked at, we have a copy of it here. It just looks to me like you got these deep water or deep areas in dark blue around what would be a peninsula that kind of sticks out.
Right, yeah, I know what you mean.
Past where this Flippo well is and Morro Bay 1 and 2. Right. So those are the high school wells on the north side, right?
Yeah, that's right.
And they're not really part of this. We're not going to be using them for production, are we?
Those high school wells are actually operated by the city of Morro Bay. So we can use those for production, or we operate them for the high school for irrigation, depending on how we're running our brackish water RO facility and what the status of state water is.
Okay. So again, I'd like to come back to what Larry Truesdale wrote here, because it'd be nice to get some kind of response as to the sources of the nitrates. And as I read your report, of course, you're looking at the agricultural nitrates coming down the valley. And what Truesdale is referring to is something else, some other sewage material that's coming from the north, Cayucas Pipeline, North Morro Bay. And of course, it's very disturbing. So I just would like to have you address, what do we, is this an issue? Is it not an issue? It'd be nice to know something more about it.
Well, I would just like to say that Dave O'Rourke was the GSI staff member who actually ran the model. Unfortunately, he couldn't be here today, so I'm here in his place, and I'm not as familiar with the model. But he conveyed to me that what he did was he input a very high concentration of nitrates all through that Narrows area, that area up valley to the northeast. And, it wasn't intended to model that scenario that you're referring to with the sewage line, but Dave's feeling was that it actually would kind of approximate that scenario almost as well as it approximates the nitrate source, which we assumed was from the agriculture. So,
not only was that assumption made, we've had a couple of appearances at the regional board. Their in-house hydrogeologists, in addition to work done by Cleath and Associates, have determined that the most likely source for nitrate is up valley agriculture. So over application of high nitrate fertilizer. There's some reference in here to sucralose being in there. Sucralose is very ubiquitous in the environment. You will find it in our state water supply because state water comes from the Sacramento River Delta, And there may be a few wastewater treatment plants that discharge to that delta area. We also irrigate the land above our wells with water that comes from state water. And there's no surprise that there's sucralose in those wells. I cannot tell you with absolute certainty that a molecule of wastewater does not enter the system. It's impossible to tell with certainty. But all the work done by previous hydrogeologists and confirmed by the regional boards, conclusion was the pollution that we're receiving in our wells is due to upstream agriculture. And you can see those nitrate levels drop as fields that used to be heavily fertilized have gone fallow.
Well, I have to say, I'm very happy with what GSI has done. I'm just trying to dig a little bit toward addressing item 4 and what Mr. Truesdale wrote, that's all. And he's making this, supposedly there's all kinds of documentation is what he's referring to, including the report that GSI is referring to, by the same authors. So, in visiting the plant, I know that Joe has a lab there where they're studying, biological oxygen demand, and they're watching everything in the plant itself. And it just seems to me that the EIR, they're showing, long-term history of groundwater quality. Okay, there's a chart right there. Do any of these things that Mr. Truesdale's talking about, do they show up in the groundwater quality report?
No, I think just going back to what Rob had said, a number of hydrogeologists have kind of weighed in on where this is coming from, and also to Nate's point, we calibrated this model first before we started using it, looking at injection and different extraction scenarios and everything else. And the way that the nitrates were applied to this model was that there was a large quantity of nitrates that was put into the model upstream of the wells at a period in time that was consistent with when those fields were being heavily farmed and fertilized. And then it was calibrated on a historical time basis from going back from the early 1980s till now, and we were able to calibrate that model to show the variation of the nitrate concentration was consistent with a large concentration of nitrates coming from upstream, not a consistent source of nitrates that would be coming from another source. So there's a number of different studies out there that support the nitrates are the majority of the nitrates are coming from the fertilization of those fields from agricultural, and the modeling also helps prove that out, and the pattern of those nitrates is also consistent with the upstream ag activities that have happened historically.
Okay, well, I guess that brings me back to the high school wells, because I'm just looking for just some kind of way to see that those high school wells being on the north side of this peninsula, their groundwater quality reports would be similar to the wells that are on the up valley, I guess we'll say, the MB 13 and MB 1 and 4. So because the way Mr. Truesdale wrote this, he's saying, oh, well, there's this sewage leaking from up north Morro Bay, which means the high school wells would show more of this source of nitrate than the other wells. And I'm just asking, is there any evidence of that in your water quality reports?
The water quality modeling that was done in here was not looking at the high school wells. It was primarily focused on 3, 4, 14, and 15.
Right, I understand that.
Yeah.
But I'm just saying, since in the EIR there's groundwater quality, clearly you're monitoring all the wells when you're pumping the water out.
Yeah, I think the reason for why the analysis was done that way is there's a lot more water quality data that's available for those other wells versus the high school wells.
Okay.
And so the model could be, the more data you have, the better you can calibrate the model. And so that's the reason why, without having Mr. O'Rourke here, but I believe that was the reason why those wells were focused on, is
Right.
they could be calibrated.
Okay. Thank you.
Kind of a follow-up to those wells. In the future, when we do this recycling, will all of those wells have to be in production, or are we going to rely on just a few of them? Like 3, 4, 14? Which wells will we be using over time? Will they be running all the time when that happens?
It really comes down to time of year and how the mix of water would play in with what the city would be using in terms of state water and some other things, I think, is, I think, if you look at the city's demand, I think there's more than enough volume with all of these wells to meet the city's annual average demand, but there may be times when you've got, obviously because of peaks, more wells running.
I mean, can the well keep up with the amount we want to extract?
Yes.
And are they in pretty good working condition right now? Do they need to be, pumps need to replace or anything need to replace?
They're in good condition. We maintain them regularly. Not to say that, we can't have failures, but for example, within the last year, we did replace one of the high school wells, and, we continuously monitor the output on them. So, they are getting older, and as we use them more, there might be an opportunity in the future where we'll have to actually, replace a well or drill a new one in that area. But currently, they're in good shape and they're operational.
I think Joe meant we replaced a high school well pump, not the well.
It's okay. It's a little easier. On figure 7 of the report, it shows the nitrate concentrations, and maybe this is something you just talked about, but it looks like around year 2014, there was a spike at all locations. Was that because, why was that? Do we know? And it dropped off immediately afterwards. Was there some diluting of nitrates that was being done, or how was that? Or is it because, like you say, the fields went fallow, and that's what it immediately dropped after it spiked?
Nate doesn't have the benefit of looking at this figure that we're looking at, so, and it's not on the screen, so maybe we can share this with him so that...
Yeah, I can picture it, and yeah, I think, what you just said there, that the source was, maybe mitigated, maybe if it were the ag, fields being fertilized, it looks like it could correlate with them being fallowed, but I do not know the history of that field. Personally, I don't know when it was fallowed, but it is interesting that the levels of nitrate seem to have peaked and then come back down.
I was just curious on that. And also, just one real quick thing here, because in your PowerPoint, you keep talking about Vistra. Vistra is the company that bought out Dynergy.
Yes. They're the current owners of the Morro Bay Power Plant site.
Okay, the injection well locations you show over there on that property, is that going to be a problem with their property and encumbering it with those features? It's a coastal, very valuable coastal real estate right there. Is that, or the other thing is that I remember coastal staff saying they didn't want anything west of the highway. It seems like the injection wells are favoring that, the pipeline routes are favoring the west side. Is that going to be an issue with coastal staff, that we're putting so much on the west side when they warned us not to go there with anything?
Not based on our discussions with the coastal staff. They reviewed this material, had several meetings, and they are have not raised that as an issue and have been generally supportive of the project.
Okay. I believe that's all the comments we have. Thank you very much. Appreciate that.
Yeah, thank you.
With that, I believe that concludes our item B1.
You might want to open for public for this section of the, we took public comment on the conveyance system. You may want to open public comment for the groundwater.
Let me go to Valerie real quick.
Just one more question in regards to nitrates. I think it's the preliminary geotechnical report, Appendix C, that discusses the history of nitrate contamination and the agricultural practices. But one of the things that triggered in my mind in reading that is we're making an assumption. What if there should be some sort of intensification of different kinds of agricultural activities in the Morrow Valley, where we go back to this kind of row cropping, or the addition of more tree crops, because they do still require nitrogen fertilizer. So I'm wondering, does this take into consideration any potential for agricultural changes in agricultural practices over time? And is it sufficient that we're putting so much more water into the system that it would negate any increases?
I think the difference between now and a few years ago is agriculture now operates under an ag order, where they can no longer indiscriminately apply fertilizer to their practices or their operations. You can tell I'm not a farmer, so I don't know the exact words. And they need to report that to the region board. The region board monitors that. We have sorry, I'm stumbling for words right now, but I'm thinking that I probably should stop there and not talk any more about this, because it's something our city attorney is working on.
Good. Oh, is it time, 5 o'clock? Well, can I have a motion to extend our meeting past 5 o'clock?
I make a motion to extend the meeting another hour.
Well, however long it takes.
I'm sorry, did you say 6 o'clock?
We can go to 6, that's when the planning commission shows up, right?
Okay, let's say 5:30. I think
Okay,
we're pretty
that sounds
close.
better.
It'd be nice to give them some time to change places.
Okay.
I'm sorry. I'll make a motion to extend the meeting a half hour.
Okay.
I'll second that.
All approved?
Aye.
Aye. With that, I'd like to open it back up to the public to discuss this item on the GSI report. If anybody would like to get up and speak to the matter. Larry?
Hello, Larry Truesdale again. Since there's been so many questions about how the information, that report I distributed was come to, I'd be more than happy to answer questions or tell you how I reached these conclusions. It might take a little bit more than 3 minutes, so it's up to you, however you'd like to do it, or I can just leave the report stand as is. So if you would like more information, I can tell you right now how I achieved it, because I didn't generate any numbers. I used what's been published by the consultants. I analyzed the curves, and I can tell you exactly where things crop up that are being glossed over, and how you reach these sort of conclusions. And you can determine whether I'm dreaming or not. It's up to you. How do you want to do it?
Thank you, Larry. Do you have any questions, Doug, for Larry?
Well, I mean, we've heard that we're working on pipeline improvements and smoke testing, whatever that is exactly, I'm not sure. So I'm assuming in the long run scheme of things, whatever is the source of what you've written about is going to be reduced no matter what.
Correct.
Because I mean,
Correct, but it depends on how long the residence time of the sewage in the ground is to get down to the wells. Is it 1 year? Is it 10 years? Is it 15 or 20? I don't know that information. But clearly the isotopic labeling for nitrogen and oxygen ratios shows it very clearly has to be sewage. There could be a small amount of fertilizer from nitrates. The Cleath report, if you look at the index, they glossed over this. They measured the fertilizer and got a number which comes right on what the forensic tests for this isotopic ratio would be. And boy, there's not a chance that the major contributor in the nitrates we're seeing in the 2005 to 2007 range is from fertilizer exclusively. It's probably a very minor component. That means there's a path to get there from some sewage line, and you can only speculate on what that is. But considering the proximity of the lines coming out of Cayucas and North Morro Bay, it's probably there. It's probably somewhere around where Atascadero and Route 1 area is to get there. The model studies that GSI did doesn't show a path to get there. So there's an unknown of how it gets there. But there is a second piece of data that's really questionable. You see in the Cleath reports measuring nitrates twice a year. Peak up, peak down, peak up, and you see it every year. The error limits in measuring nitrates is very small compared to the distance between those. That means you should be getting numerous data points, maybe not every 6 months, but maybe every week or every 2 weeks, and you'll get an answer for where things are coming from. But we, once a year, pump water primarily out of the valley because they shut down the state system. So we have a perturbation that hits at a very unusual time, and they measure the numbers sometime after that, and then 6 months later. That's all speculation, but the isotopic ratios are well established around the world that this is human sewage nitrates. You can't get around that. And in the Cleath report, they actually measured it and showed that. They didn't discuss it. They did a different sort of discussion that doesn't fit their actual measurement of nitrates. I have not seen anywhere anyone going out and determining what's going on in the farming. They say these are general practices, so this must be what it is. A very reasonable assumption, except you have a fact that you can't get around. And then you have sucralose. It's everywhere, yeah. At 175 parts per million in the wells down by the high school, that's not trace. That's a big number. It's in sewage at high levels compared to what comes off the fields and farms, because it's of no value in farming. Those farm areas cover a large area. Just analyzing data. I don't generate it, I don't create it, but the scientific methods that the Cleath people used are not the type of science I would like to see done, and I wouldn't do that. I wouldn't write a report on it because you don't have sufficient data to reach the conclusions except for the isotope ratios. That's immutable.
Thank you, Larry.
Okay.
I have a question as a follow-up probably for Joe, because didn't you just mention that one of your problem areas is in the Highway 41 Tascadero Road area for the sewer lines? That's where your smoke testing is problematic?
No, actually, where we've been concentrating our smoke testing efforts has been out on the beach track area.
Okay.
So that's where we have done it twice since I've been here with the city.
Could there be a problem that's suspect in the sewer lines in the vicinity that Larry's talking about down there in Tascadero Road in that area?
There could be. Like I said, right now we're concentrating on the higher impact areas that I know of, and focusing on that. Maybe Rob could add something to that.
We review this information regarding nitrate contamination in our wells with regional board, scientific staff. The board, they made different conclusions than Mr. Truesdale did, that the isotopic ratio was related to agricultural nitrate contamination. Getting a little feedback there. And they recommended no further action regarding investigation of the source of nitrates based on the conclusion that it came from upstream agriculture.
Okay. Valerie?
Just at the area that the problem area that you were talking about, Doug, isn't that similar to Main Street and Atascadero Road where you do have a project planned?
Yeah, Atascadero Road project is a capacity issue. That line had an in situ form lining placed, inversion lining, so a liner that was placed in that pipeline, because that's how the MTBEs entered the sewer. It was, and then Shell Equilon paid for the lining of that line. Main Street does have significant cracking and offset joints along there, and it also is a capacity issue there. So that line needs to be replaced for a couple different reasons, capacity and joint issues. Much of the year, our pipes in that area are underwater. There's not a chance that there is exfiltration occurring when those lines are underwater. The hydraulic pressure from the groundwater is higher than the pressure that is in the pipes. That's why we get water into our pipes.
That's all clay pipe out there, isn't it? Pretty much.
There's some concrete, there's some clay. We have almost every pipe variety in our system.
Ever made. Thank you.
Okay, with that concludes our item tonight. Is there any other comments from the committee or staff?
Just that you'll be seeing the next phase of the report, following phase, and then a final hydrogeological report that wraps everything up together.
Okay, good. Thank you.
A question, Rob, could you just, the pipe you were just talking about that's submerged, where was that?
Main Street?
In Main Street, Atascadero Road, both those pipes are underwater a lot of the year, especially when you have high groundwater. And now, during the drought, I think they were pretty dry. We weren't getting a whole lot of water coming in when it wasn't raining, but as with a lot of cities, the sewer lines tend to be underwater a lot of the year.
What part of Main Street? North of Atascadero Road or just right around Atascadero Road?
North and south of Atascadero Road. Just because of the groundwater elevation and the depth of the sewer line. So I don't know how well this is going to show up on camera. So Main Street flows to Atascadero Road, comes some of the deepest part of the system. That's why when we're looking at perhaps a lift station up closer to Atascadero Road, we're talking if you remember from when we were looking at that, huge depths on wet well depths, 30, 40 feet depths of wet wells. So it'd have to be quite deep to intercept those sewer lines there.
All right, with that, we're adjourned. Thanks, everyone.